VGA, DVI, HDMI, DisplayPort, USB-C, or Thunderbolt. The oldest computer display connector in common use is the Video Graphics Array, or VGA. Introduced by IBM in 1987, this uses a standard 15-pin D-shaped sub-miniature or D-sub connector. These are sometimes color-coded blue and usually feature two screws to ensure a robust connection. However, Apple, HP, Samsung and Asus did once make their own proprietary mini VGA connectors for use on some of their laptops. VGA carries analog video signals and no audio, and was initially designed to support a resolution of 640 by 480. However, it's now used to deliver higher resolutions that include 800 by 600, 1024 by 768, 1280 by 1024, 1920 by 1080, and 2048 by 1536. This said, because VGA is analog and not digital, some people find VGA images with a resolution of 1920 by 1080 or higher to be fuzzy. For example, in my recent video on the Orange Pi 800, where I compared its VGA and HDMI outputs, some viewers commented that the two 1080p signals looked identical, whilst others thought that the VGA output was significantly blurred. So, the maximum comfortable VGA resolution depends on individual perception. Following VGA, we come to the Digital Visual Interface, or DVI. This was introduced in 1999 by the Digital Display Working Group, and despite its name, may carry both analog and digital video signals, but no audio. Many different DVI connectors are available, which have the same form factor, but different pins. Specifically, there are configurations known as DVI-A, DVI-D, and DVI-I, with DVI-D and DVI-I connectors also able to be single or dual link. So, let's take a look at the 5 possible options. Firstly, and most rarely, there are DVI-A or DVI analog only connectors which just have the pins for carrying analog video. Secondly, there are single link DVI-D or DVI digital only connectors which have 2 blocks of digital pins but lack the 4 pins for analog transmission. Thirdly, there are single link DVI-I or DVI integrated connectors. These add back in the analog data pins, so allowing both analog and digital signals to be transmitted. In the initial specification, DVI-A and single-link DVI-D and DVI-I were indicated to support maximum resolutions of 1600 by 1200 or 1920 by 1080 at a frame rate of 60 Hz. However, NVIDIA and others managed to tweak things to achieve 1920 by 1200, which is the maximum practical resolution for single-link DVI. Moving on, dual-link DVI connectors add in 6 extra digital pins. These carry a second copy of the digital red, blue and green signal components, so allowing a higher digital resolution. This was initially specified as 2048 by 1536, but in practice today is up to 2560 by 1600 at 60 Hz. So, dual-link DVI allows a resolution higher than HD, but does not support a 4K display. For many years, almost all graphics cards with a DVI socket were DVI-I. This made it possible to use a simple, non-powered or passive adapter like this one to connect a VGA monitor or projector. But today, the DVI ports on most graphics cards are DVI-D or digital only. Here, for example, the DVI port on this computer is dual-link DVI-D. So, if we wanted to connect a VGA monitor to this port, a simple passive adapter would not work. Rather, we'd need to use a more expensive active or powered adapter to convert the digital DVI signal to analog for VGA. The High Definition Media Interface, or HDMI, was introduced by a group of 7 TV and computer manufacturers in 2002. HDMI also features a standard called CEC, or Consumer Electronics Control, that allows one device, such as a television, to control another, such as a DVD player. In addition, HDMI can carry copy protection information known as HDCP, or High Definition Copy Protection. And, using an appropriate cable, some HDMI connections can also carry an Ethernet network connection. In total, 5 different HDMI connectors have been specified. These bear the letters A to E, although they're also known as standard or full size, dual link, mini, micro, and the automotive connection system. Of these, only standard, mini, and micro connectors are found on computers and end-user displays. In fact, the dual-link connector was specified way back in 2002 based on DVI-D dual-link, but has never been used in any products. Meanwhile, the automotive connector is based on Type A, but has the advantages of being fully shielded and incorporating an anti-shock locking mechanism that the other connectors sadly lack. Over the past 20 years, the HDMI standard has been constantly upgraded. Significant revisions included HDMI 1.4, which introduced support for both 4K and Ethernet over HDMI. In 2013, HDMI 2.0 also increased available frame rates at 2K to 240 Hz and at 4K to 60 Hz. And HDMI 2.1 now offers 4K at 120 Hz as well as 8K and even 10K resolutions. Note that to use 4K and higher resolutions, as well as Ethernet over HDMI, appropriate cables are required. Finally, it's worth mentioning that HDMI video signals are identical to DVI. This allows the creation of low-cost, bidirectional DVI to HDMI cables and adapters that will work at all DVI-supported resolutions but with no audio. DisplayPort was developed by the Video Electronics Standards Association, or VESA, in 2006. Both full-size and mini connectors are available, and DisplayPort signals can also be transmitted via USB Type-C or Thunderbolt connector, as I'll discuss later in the video. Like HDMI, DisplayPort transmits both video and audio and supports both HDCP copy protection as well as its own standard called DisplayPort Content Protection, or DPCP. However, DisplayPort cannot carry an Ethernet network connection, but it can be daisy-chained with a feature called Multi-Stream Transport, or MST, allowing one DisplayPort output to drive multiple monitors. Full-size DisplayPort connectors look quite similar to Type A HDMI, but are only tapered at one end. A full-size DisplayPort plug also includes a twin-tooth locking mechanism that is disengaged by holding down a button. So, once a full-size DisplayPort plug is inserted, it will not accidentally pull out of the socket. It's important to note that the signals transmitted by DisplayPort connectors are not compatible with HDMI or DVI-D, as they use different methods to transmit packets of data, as well as a voltage level of 3.3 rather than 5 volts. This said, the DisplayPorts on some devices do have the ability to detect an HDMI or DVI-D monitor and to reconfigure themselves to output appropriate signals. Such dual-mode DisplayPorts are labelled DisplayPort++ or DP++ and can be connected to an HDMI or DVI monitor using a simple DisplayPort to HDMI or DVI lead or passive adapter. DisplayPort has been constantly upgraded, with higher resolutions and frame rates delivered ahead of HDMI. For example, DisplayPort 1.2 offered 4K at 60 Hz back in 2009. 8K then arrived in 2014 and 16K in 2019 with DisplayPort 2.0. As always, appropriate cables are required to achieve such resolutions. And to try and assist with such matters, in 2022, VESA launched a new certification called DisplayPort UHBR, or Ultra-High Bit Rate. This certifies cables. While so far we've been looking at dedicated display connectors, it's also possible to hook up a monitor to some USB Type-C ports. For this to work, the port must support an alternative or out mode, and specifically either HDMI out mode for USB Type-C or DisplayPort out mode over USB-C. In the former instance, the USB-C port will allow connection to an HDMI monitor up to 4K in resolution at 30 Hz. And if the port is rated for DisplayPort over USB-C, it may support 4K displays at 60 Hz and even 8K displays, although this will depend on the particular device and port specification. This said, do note that DisplayPort Dual Mode, or DP++, is not available via a USB-C port. To connect a computing device to a display over USB-C, an appropriate cable will of course be required, such as this USB-C to HDMI lead. And if you're wondering how you can tell if a particular USB-C port supports video output, it may bear an HDMI or DisplayPort logo. But the only sure way to tell is to look in the computer's manual or other documentation. Thunderbolt was developed by Intel in conjunction with Apple and first released in 2011. It can be used to connect a wide range of peripherals, to deliver power, and to transmit video and audio to a monitor using standard DisplayPort signals. The first two versions of Thunderbolt, called Thunderbolt 1 and Thunderbolt 2, use the same connector as Mini DisplayPort. However, for Thunderbolt 3 and the most recent Thunderbolt 4, a USB Type-C connector has been adopted. Appropriate cables must be used, which, like Thunderbolt sockets, will bear a Lightning symbol if they're certified products. As with other display connectors, maximum resolutions and frame rates have been upgraded over the years, with Thunderbolt 4 ports supporting up to one 8K 60Hz display, two 4K 60Hz displays, or one 4K 120Hz display. Such displays may have either a Thunderbolt or a DisplayPort connector, or an active adapter may be used to connect to HDMI, DVI, or VGA monitors, or a serial digital interface that's used in professional video. But in computing, the most common display connectors remain those we've looked at here. And in the future,